congruent to another. And so there are three properties that come off an awful lot as we do this. One of them is called a reflexive property. And oftentimes we also call this one either shared side or shared angle, but that's any line or angle is congruent to itself. So you can see over here in the diagram that these two triangles share this side in common, FH. So we can therefore say, due to the reflexive property, that FH, that line segment, is congruent to the line segment HF. The second one is we call the symmetric property, and that is if A is congruent to B, then B is congruent to A. So that just makes common sense that the reverse would be true. The next one we call is called the transitive property, and that's if A is congruent to B and B is congruent to C, then A must be congruent to C, which also once again makes perfect sense because C is congruent to B and A is congruent to B, so therefore if they're both congruent to B, they must be congruent to each other. And then finally, the last thing is, and we often say this at the last part of proving one triangle is congruent to another one, is we'll say that those congruent triangles have congruent parts. Parts are nothing more than the angles and sides that make up those triangles. And a shortcut way of writing out that sentence is congruent triangles have congruent parts. So that's it for that toolkit entry.